Namaskar. So today, whether a screw dislocation is left-handed or right-handed, that we are going to see. So the first method is by Burger vector direction. So if we know what is the direction of Burger vector, from that we can interpret it, or we can say that the screw dislocation is going to be a left-handed or right-handed. For that, we should know that what is left-handed and right-handed screw, because it is more aligned, or it is more similar to the left-handed screw and right-handed screw. So left-handed screw or a left-handed thread, as you can see, it is a screw where the screw moves forward when it is turned from right to left, right? So this is the right side, and this is left side, right? So if you turn the screw from right to left and it moves up, okay, it's moved forward, right? So it is called as left-handed screw. If I take a right-handed screw or right-handed thread, what happen? This is left side and this is right side, right? So if the screw rotates, let's say from left to right, and during that rotation, if it is moving forward, or let's say up, if it is moving forward, it is called as right-handed screw or right-handed thread, right? So this is clear that in left-handed screw, when the screw rotates anti-clockwise, it moves forward, while in right-handed screw, when it moves clockwise, it moves forward. Now in this, what we need to see, that the direction of thumb is giving me the direction of forward motion. Now this direction of thumb we will consider as a Burger vector for our case, interpreting that the given screw dislocation is left-handed or right-handed. We have to focus on the direction of thumb and the curling of finger. So these two things are required. So let's see how can we use this. This is a screw dislocation which is clearly visible, because we have a two part, right, which has got sheared off two part of this crystal lattice. So now we have to start by making a Burger circuit. So to start making a Burger circuit, what we need that we should start from a point, and that point you should take where the dislocation is originating, or so the dislocation in this case is at this location where I have used S green mark, right? I am taking that S or this green point as a starting point. Now the dislocation is located within this region, so that's why I'm taking the S or the starting point within this region. Now to create the Burger circuit, what we have learned, that in the edge dislocation we are moving throughout the crystal with the same distance in all the directions, and we are coming to a final position. Same as we will do in this case also, we are now move from left to right in this case, right? So let's say I'm moving a distance of 1.5, where this is 0.5 and this is 1, so I'm moving a total 1.5 distance, and where the lattice is now not distorted, right? So we have to move from a distorted lattice to a non-distorted lattice. Now I will move upward, up direction, and let's say I move a distance of 1 2 3 4 units, right? So I move 4 units in up direction, which is, let's say, positive y. So let me denote this. This is a positive x, this is positive y. Now as I moved some distance in x direction, which is 1.5, as in this case I will move a more than 1.5 distance. Let's say move up to a distance of 3. It's up to you, you can move also distance of 4 units, it's up to you. 2 units is also fine, but let's say move a 3 units in negative y direction, which is shown this. Now as I moved 4 units in positive y, I have to again move minus 4 units in positive y, or I would say 4 units in negative y. So I will move negative 4 units or 4 units in negative y direction. Now as you can see, I have already traveled 1.5 distance in positive x direction. So right, I have moved up 1.5 in positive x direction earlier from starting point. However, I have moved 3 units in negative x direction. So to compensate, so what distance I have to move so that I can compensate, or I can reach a 0 unit in both this? So I have to move a distance of again 1.5 units so that I can equalize, I can balance the 3 distance, because I have to complete the circuit, right? It has to be a closed circuit. So I will move a distance of 1.5 again, which is 1, and this is 0.5, and this is the finishing point. So that completes making of burger circuit. But as you can see, the burger circuit is not closed, and it is not, as it is not closed, it means that there is some dislocation. If it is was closed, that means there was no dislocation in this case. But as we are getting that the starting point and the finishing point is not overlapping, or they are not the same, that means the dislocation exists. Now what we will do, we have to connect the finish and the starting point, right? We have to connect from the F or the finish point to the S or the starting point. So this direction will give me the burger vector direction. So now I got a burger vector for the screw dislocation in this way. Now what we will do, we will have to now use the right hand rule and the left hand rule that we have seen. So over here, B is the burger vector. The red lines that we have used, these are the burger circuit, and the direction of burger circuit is from, like, it's an anti-clockwise direction, because we have moved from right to left. So it's an anti-clockwise burger circuit direction. So these blue arrows, they will show the burger circuit direction. Now we will use left hand and right hand to see which hand is best fitted with this burger circuit, right? So let's take the right hand first. I have taken this right hand and I will place this such that I have to curl the fingers. I have to curl the fingers in the same direction of burger circuit direction, right? So as it is moving anti-clockwise, counterclockwise, I have to curl the finger in counterclockwise direction. I have to align these fingers in the same direction. After aligning that, what we can see, that the direction of thumb is up, and this is the direction of the burger vector, right? It has to be the direction of burger vector if it was the right hand screw dislocation, but we are not getting the burger vector in up direction. So now let's check with left hand. So I'm going to check with left hand. This is the left hand, but as you can see, if I place the left hand in this view, what can happen? I am saying that this direction of curling of finger, it is from right to left. It is not counterclockwise, it is clockwise. I should not use the left hand in this way, right? What should I do? I have to rotate my left hand such that the curling of finger should be counterclockwise. So this is good. This looks good, that the fingers are counterclockwise and they are aligned with the direction of burger circuit. Now in this way, in this left hand, when I align the curling of fingers in this direction with the burger circuit, the direction of burger vector or the direction of thumb, it comes out to be downwards, which matches with the acquired burger vector for the burger circuit. So that means this is a left hand screw dislocation, because the left hand matches with the burger circuit and the burger vector direction. So in this way, we can decide by using a burger circuit and the burger vector what is the type of screw dislocation. Now let's take this case. So we have to start making a burger circuit, right? So what we will do, I'm taking this is as starting point. This is the starting point, and I have to move some distances. So let's say in this case I'm moving 1, 2 and 3. So I have moved 3 units in this case, and let me provide you the axis coordinate, the axis, so that you can know what we are doing. So this is going to be x and this is y, right? So I'm moving generally in x and y, so I'm not using z direction right now, which otherwise the z direction is going to be this, but let's keep it like this. So this is the z direction. So I have moved 3 units, this 3 units in negative y direction, right? So I moved 3 units in negative y direction. Now I will move, let's say 1, 2, 3, 4, 5 and 6. I have moved 6 units in positive x. Now I have moved 3 units in negative y, and I am started with at a s point, the starting point, which where the dislocation is existing. So I should move more than 3 units, right? So I will move now 3 units in positive y, okay, and then I will take much 2 or 3 more units. I am taking 3 more units, 1, 2 and 3, right? So total I have moved 6 units in positive y. As I moved 6 units in x direction, I have to again use, or I have to move 6 units in negative x direction, so that it should be balanced out. 6 distances in the x direction. So now 6 distances in x and 6 distance in negative x, they are now balanced. However, I have remaining 3 units, right? Because I have moved 3 units in negative y and 6 units in positive y. So 6 minus 3 and 3. So 3 units is remaining that I have to move in y direction. So I can move 1, 2, 3 units in negative y direction, so that I can compensate this positive 6, right? So this is the 3 units that I moved, and this is going to be my finishing point for the current burger circuit. Now what we can see that the starting point and finishing point is not the same. I will connect starting with the I will connect the finishing point with the starting point, and this will give me the burger vector direction. So I got the burger vector for this current dislocation. Now how to know that whether this burger vector it relates to left hand or right hand screw dislocation. So what we will do, we will take either left hand or right hand, right? We will take any of we will take first, let's say, left hand, and we will see that whether it is aligning with this or not, right? So to cross check this, I am just going out of this slideshow mode, and let me take this, right? Now I have to curl the finger. So this is a kind of counterclockwise rotation, right? I have to curl the fingers in counterclockwise rotation. So this is, and if I rotate like this, right, this is a kind of this fingers, now it is in counterclockwise rotation. However, the direction of thumb, you can see that it is going inside, right? If I draw the direction of burger vector with the thumb direction, it is like this. However, we are getting this, right? So what is mean that this is not a left hand dislocation, right? This is not a left hand dislocation, because this left hand is not fitting into this case. So let me put it aside, and I will take this right hand. I will align the fingers, and this is aligning in this way, no, right? If I rotate it like this, yes, now it is aligning in counterclockwise rotation, right? So as you can see, the fingers are aligning in this, and the burger vector or the direction of thumb is in the same direction as B vector, which we are getting for burger circuit. So it means that this is a right hand screw dislocation. So that's the first way of, or I can say the first method to determine what type of screw dislocation it is, either a left hand or right hand. Second method is very easy, it's the movement along the slope. So a left-handed helix and by right-handed helix, we can know that what will be the screw dislocation. So in left-handed helix, if you are standing, let's say on a helix, and if you want to move to upper position, right? If you want to move to upper position, so what you will do, you will moving from right to left. That is a left-handed helix. Right-handed helix, you are moving from left to right to a upper or a higher position, right? So this is the two ways where we can know that what is a left-handed helix and right-handed helix. By using this, we can interpret what will be the screw, what type of screw dislocation it would be. Considering the same example, this example, now as we have seen that in a helix I have to move from lower to higher position. So in this case, this is a lower position and this is a higher position or high altitude position, right? So I have to stand at a lower position, which is this. Now if I want to move to a high position, what should I do, right? I will take a helical path which is moving from right to left like this, right? And this movement along a helical path is similar to the left hand helix where I am moving like this. Same path I have taken in the dislocation, in the dislocated crystal lattice. So the same path I have used, which is similar to the left-handed helix. So that means this is a left-handed or left-hand screw dislocation. Second case, this one over here, where is the lower altitude or the lower depth part is this one, high altitude or high position is this one. So I should stand at a lower position and move to a higher position. So this is the path that I am taking. Now this path, in this path I am moving from left to right. Let's see this. This is a left-handed and this is a right-handed. If you try to make this movement align with either of these two, what we can see that you are moving on the right-handed helix, right? That means this is a right hand screw dislocation similar to what we have seen in the by using a burger circuit. This is the second method, by using a helix to find whether the screw dislocation is right hand or left hand. The third and the last method is by slope of dislocation. So to use this method, we should also know that what is the slope in a left-handed screw and right-handed screw. So in left-handed screw, what we are saying, this is the slope, right? This is the slope and this slope is a negative slope. So in a left-handed screw, the slopes are negative, and in right-handed, this pink shaded region is a slope which is a positive slope. So, right? So in left-handed, the slope is negative, in right-handed, the slope is positive. So similarly, if in a screw dislocation, if the slope comes out to be negative, it is going to be left-handed screw dislocation, and if the slopes comes out to be positive, it is going to be right-handed or right hand, it is going to be right hand screw dislocate. Let's use this method to check. This is a deformed crystal lattice and I should make a slope, or I should try to create a slope in this, and the slope, it can be easily visualized that how to, the slope generally happens where we have unaligned planes, and the unaligned planes are, this is the one and this is the second, right? These are the unaligned planes. However, this plane is aligned, they are perfectly fine, the slope is 0 in this case. So in this case, where I have a plane, let's say 1, a plane P1 and plane P2, by using these two planes, what we can see that the slope is going to be like this, right? So I have a higher height at this location, this is the 0, right? So this is the slope, and this slope resembles to negative slope, right? So this slope is a negative slope, and if it is a negative slope, what it means, it's a left hand screw dislocation. Let's take the next example, similar example. In this case, to create a slope, we need two planes which are unaligned and having some height difference. So these are the two planes where they are not perfectly aligned, and the slope would be in this manner. Right now it's difficult to interpret it, so what I will do, I will rotate it. So this is the simplistic or the actual view of a slope as we are seeing from the screen, and this slope, it seems out to be positive, right? Because the slope is increasing from when we are moving in the x direction. So it is a positive slope and it is a right hand screw dislocation. So in this way you can easily interpret it, easily know what will be the type of screw dislocation, left hand or right hand. So taking an example, this is an example, please try, this is a kind of a homework, see what kind of screw dislocation you are getting, comment in the chat box what answer you are getting and I will reply to you. Second example is this one where we have a mixed dislocation. Mixed dislocation means you have edge dislocation and screw dislocation. Just a hint either that I want to give to you. Edge dislocation and screw dislocation, it means that if both are present, there should be one atomic plane which is inserted between the crystal lattice. So this is the atomic plane which is inserted and there is no atomic plane beneath it. That means it is a edge dislocation. In this case, try to find it out what kind of screw dislocation it is, right hand or left hand, and provide your comment, provide your answer in the comment box. Thank you. If you like the video, hit the like button and share it to your friends so that they can also learn